Hello, hi everyone. Welcome to the Student Brand. This is Ever Shiva sir. Today we are going to discuss about light refraction. Light refraction. In the previous live class, we discussed light reflection. Now we will discuss light refraction. Okay, so we'll see. So light refraction. Now we will discuss about light refraction. So when the light ray is passing from rarer to denser, when the light ray is passing from rarer to denser, this is the rarer medium and this is the denser medium. If the light ray is passing from rarer to denser, okay, so at the interference of the two media it will bend. At the interference of the two media it will bend. So here I am taking the light ray will bend at the interference of the two media. So the path of the light changes. The path of the light changes at the interference of the two media is called refraction. The path of the light changes at the interference of the two media is called refraction of light. Is called refraction of light. The angle between incident ray and normal line is called angle of incidence. Angle between refracted ray and normal line is called angle of refraction. Angle of refraction. If the light ray is passing from rarer to denser, if the light ray is passing from rarer to denser, okay, so angle of incidence is greater than the angle of refraction because so the refracted ray bend towards the normal line. The refracted ray will bend towards the normal line. Towards the normal line. Okay. So same thing. The light ray passing from denser to rarer. So this is the rarer medium and denser medium. If the light ray passing from denser to rarer. So the light ray will move away from the normal line. So this angle of incidence and this is called angle of refraction. So in this case, angle of refraction is greater than the angle of incidence. Angle of refraction is greater than the angle of incidence because the light is moving from rarer to denser. Light ray is moving from rarer to denser, bends towards the normal line. Light ray is moving from rarer to denser, bends towards the normal line because speed is decreasing. Speed is decreasing. If the light ray is moving from denser to rarer, so it is moving away from the normal line. The refracted ray moving away from the normal line because so speed is increasing. Speed is increasing, right? Speed is increasing. Speed is increasing. So the bending of the light at the interference of the two media, the bending of the light at the interference of the two media is called a refraction of light, or the path of the light changes at the interference of the two media. The path of the light changes at the interference of the two media is called a refraction. Light ray is moving from rarer to denser, it bends towards normal. If it is moving from denser to rarer, it moves away from the normal line. Speed of light is more in the rarer medium than in the denser medium. Suppose rarer medium, if I am taking air I am considering here air and water. Air and water. Okay, air and water if I am considering, or air and glass also if you consider. Suppose so speed of light is more in the rarer medium than in the denser medium. So refractive index is more in the denser medium. So what is the refractive index? So if you want to learn about it, first we have to discuss about laws of refraction. Laws of refraction. Laws of refraction, sir. Okay, there are two laws of refraction. One is incident ray, refracted ray, normal line lies in the same plane. First one. Incident ray, refracted ray, normal line. I'm consider first one, laws of refraction. Laws of refraction. First one, incident ray, refracted ray, normal line. Incident ray, refracted ray, normal line lies in the same plane. Second one, second one, second one is sine of angle of incident to sine of angle of refraction equal to constant. Sine of angle of incident to sine of angle of refraction equal to constant. Sine of angle of incidence to sine of angle of refraction equal to constant. Sine of angle of incident to sine of angle of refraction equal to constant. So n is the refractive index. 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 N equal to c by v. N equal to c by v. So n is the refractive index. So the ratio of speed of light in vacuum by speed of light in medium. N equal to c by v. The ratio of speed of light in vacuum by speed of light in medium. The ratio of speed of light in vacuum by speed of light in medium is called absolute refractive index. Absolute refractive index. Absolute refractive index is nothing but the speed of light in vacuum by speed of light in medium. The speed of light in vacuum by speed of light in medium. The speed of light in vacuum by speed of light in medium is called absolute refractive index. Whereas relative refractive index is n to 1. So I am taking here n to 1. N to 1 equal to n2 by n1. That is nothing but v1 by v2. So n12 equal to n1 by n2, that is equal to v2 by v1. So this is about a refractive index. Relative refractive index. This is a relative refractive index. This one is absolute refractive index. Absolute refractive index. Absolute refractive index. And this one is the relative refractive index. Relative refractive index. Okay, so this is about absolute refractive index. This is the relative refractive index. Absolute refractive index is nothing but speed of light in vacuum by speed of light in medium. Speed of light in vacuum by speed of light in medium is called absolute refractive index. Relative refractive index is nothing but speed of light, refractive index of medium 2 by medium, refractive index of medium 2 with respect to medium 1 is equal to v1 by v2, because from this one, so from this equation, we can conclude that n is inversely proportional to velocity. N is inversely proportional to velocity. N is inversely proportional to velocity. So once again, refraction means the bending of the light ray. So the bending of the light ray, the The bending of the light, the interference of the two media is called refraction of light, or the path of the light changes at the interference of the two media, or the direction of the light ray changes at the interference of the two media is called refraction. Is called refraction. Okay. So loss of refraction. Loss of refraction. Incident ray, refracted ray, normal line lies in the same plane. Incident ray, refracted ray, normal line lies in the same plane. Sine of angle of incident to sine of angle of refraction equal to constant. Sine of angle of incident to sine of angle of refraction equal to constant. Okay. So sin I by sin r equal to n. So that is n equal to c by v. This is absolute refractive index. Absolute refractive index. Absolute refractive index. Okay. Speed of light in vacuum by speed of light in medium. Speed of light in vacuum by speed of light in medium, that is equal to, so n equal to c by b. So n21 if you are taking, so refractive index of medium 2 with respect to medium 1, that is equal to n2 by n1 equal to v1 by v2, that is n12 equal to n1 by n2 equal to v2 by v1. Okay, so inversely proportional. N is inversely proportional to velocity. N is inversely proportional to velocity. So that is nothing but relative refractive index. Relative refractive index. So this is about refraction. So this is about refraction, loss of refraction, and absolute refractive index and relative refractive index. Okay. So next we will discuss about one more, that is critical angle. Critical angle. So now we will discuss about critical angle and total internal reflection. So light ray is passing from, if the light ray is passing from denser medium to rarer medium, what happens normally? So this is the rarer medium and denser medium, rarer medium, denser medium. The light ray passing from rarer, denser to rarer. So generally it moves away from the normal line. So this is the angle of refraction and angle of incidence. Angle of incident and angle of refraction. Okay. And the second case is, so if the light ray is passing, if the light ray is passing from denser to rarer, if the light ray is passing from denser to rarer, denser to rarer, denser to rarer, what happens here? At certain angle of incidence, at certain angle of incidence, at certain angle of incidence. So first one, first carefully observe, that is, if the light ray is passing from, if the light ray is passing from denser to rarer, if the light ray is passing from denser to rarer, so normally it moves away from the normal line. If the light ray is passing from denser to rarer, normally it moves away from the normal line. Okay, away from the normal line. So the angle at which, 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 The refracted ray passes or gauges along the surface. The refracted ray passes or gauges along the surface. That angle is called critical angle. That angle is called critical angle. The angle at which the refracted ray, the angle at which the refracted ray passes or gauges along the surface, that angle is called critical angle. This angle is called critical angle. And the same case, the light ray is passing from denser to rarer, light ray is passing from denser to rarer. Okay, so I'm taking here like this. Okay, so the angle at which the refracted ray makes more than 90 degrees. The refracted ray makes more than 90 degrees or more than critical angle. The refracted ray makes more than critical angle or more than 90 degrees with the normal line. Then that will reflect back into the same medium. That will reflect back into the same medium. This is 90 degrees and this is theta. Total is more than critical angle. More than critical angle. So the refracted bends, the refracted ray bends, the refracted ray moves into the same medium. Okay, it reflects back into the same medium. So this is called total internal reflection. Total internal reflection. Okay, so total internal reflection. The light ray is moving from denser to rarer. Once again, normally if the light ray is moving from denser to rarer, it moves away from the normal line. Light ray is moving from denser to rarer, it moves away from the normal line. So the angle at which the refracted ray makes 90 degrees with the normal line. Refracted ray makes 90 degrees with the normal line. So that angle is called critical angle. That angle is called critical angle. The angle at which the refracted ray passes or gauges or moves along the surface, or it makes 90 degrees with the normal line, 90 degrees with the normal line, 90 degrees with the normal line. So that angle is called critical angle. That angle is called critical angle. If the light ray is passing from the light ray is passing from denser to rarer, the light ray makes more than 90 degrees, it makes more than critical angle, then the light ray will reflect back into the same medium, so it is a more than 90 degree, 90 plus theta, more than 90 degrees, so it reflects back into the same medium. So this phenomenon is called total internal reflection. So the light ray will reflect back. So total light reflect back into the same medium. So total light internally reflection takes place. That is called total internal reflection. Total light reflect internally. That is known as total internal reflection. Once again, light rays passing from denser to rarer, it moves away from the normal line. So the angle at which the refracted ray passes, gauges, moves along the surface or makes 90 degrees with the normal line. That angle is called critical angle. So the refracted ray makes more than 90 degrees or makes more than critical angle, that reflect back into the same medium. So total light reflect internally. So that is known as total internal reflection. So this is about critical angle and total internal reflection. Critical angle and total internal reflection. Okay, so next one. Next we will discuss about spherical lenses. Spherical lenses, spherical lenses, spherical lenses, spherical lenses, spherical lenses, spherical lenses. Okay, so next we will discuss about spherical lens. Okay, or lens. Simply we can say lens. Lens, 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 lens. So here I am considering, I'm giving. So here, so I pinned the Instagram page. So kindly do follow my Instagram page. Okay, so I pinned it. You can check once. You can check my Instagram page. Right. So next one. Spherical lenses. There are two types of lenses: convex lens and concave lens. Convex lens and concave lens. Concave lens and convex lens. Convex lens. Concave lens. Concave lens. So now we will discuss about ray rules of lens, ray rules of convex lens and concave lens, ray rules of concave lens and convex lens. So light ray is passing parallel to the principal axis. After that passes through focus. Light ray is so light ray is coming from infinity parallel to the principal axis. After refraction passes through focus. Second one. Second one, optic center F1, 2F1, F2, 2F2. Light is passing through our focus. After refraction passes towards infinity. And the third one, pole optic center F1, 2F1, F2, 2F2. Light rays passing through optic center. No deviation takes place. And coming to the concave lens. Concave lens. Concave lens. Optic center F1, 2F1, F2, 2F2. Light rays coming from infinity to the principal axis. After refraction passes through F1. Second one, Third one. Light rays passing through optic center. Here you can see light ray is parallel to the principal axis, after that passes through focus. Light ray passing through focus, after that moves towards infinity. Light ray passing through optic center, so no deviation. Here also light ray passing parallel to the principal axis, after refraction it will move away from the principal axis. Light ray passing through the focus, after refraction it become parallel to the principal axis. Light ray passing through the optic center, so no deviation takes place. So this is about ray rules of concave and convex lens and concave lens, ray rules of convex lens and concave lens. So we'll discuss now. Here Light rays are coming from infinity, object is at infinity. So after refraction, light rays will meet at focus F2. So nature of the image is real and inverted. Size of the image is highly diminished. Highly diminished. So optic center F1, 2F1, F2, 2F2. Object is placed beyond 2F1. Object is placed beyond 2F1. Image will form between F2 and 2F2. So one lighter I am taking like this, it passes through focus. Another light ray passing through optic center. The image will form. So image will form here. So between 2F2 and F2 and 2F2, F2 and 2F2. So next one. So object is placed beyond 2F1. Beyond 2F1, image will form between F2 and 2F2. F2 and 2F2. Nature of the image is real inverted and diminished. Real inverted and diminished. So coming to the third one. So optic center F1, 2F1, F2, 2F2. Object is placed at 2F1. Object is placed at 2F1. Image will form at 2F2. Object is placed at 2F1. Object is placed at 2F1. Image will form at 2F2. So here object is placed at 2F1. One light I am taking like this, it passes through focus. F2 and 2F2. So one light I am taking like this. So object is 2F1. Image will form at 2F2. Nature of the image is real and inverted and same size. Same size. And coming to the fourth one. Object is placed between 2F1 and F1. Object is placed between 2F1 and F1. Image will form. One light ray I am taking. How many light rays are required to form the image of the object? Minimum light rays. So minimum light rays are required to form the image of the object. Minimal light rays. Minimal light rays are required to form the image of the object is 2. So one light ray I am taking, it passes through focus. Another light ray. Object is placed between 2f1 and f1. Image will form beyond 2f2. Image will form beyond 2f2. Beyond 2f2. Nature of the image is real and inverted. Size of the image is enlarged. Compared to the object, image size increased. Size of the image is enlarged. Okay, or magnified. And coming to the next one, sixth one. Sorry, fifth one. So object is placed at f1. One light ray I'm taking like this passes through focus. Another light ray passing through optic center. So object is at f1. Image will form at infinity. Nature of the image is real and inverted. Nature of the image is real and inverted. Size of the image is highly enlarged. Okay. Coming to the sixth one. Sixth one. Object between F1 and O. Object is placed between F1 and O. Object is placed between F1 and O. Image will form same side of the object. Same side of the object. Same side of the object. Nature of the image is virtual erect. Virtual erect. Virtual erect and enlarged. Virtual erect and enlarged. Okay. Object is placed between F1 and O. Image will form same side of the object. Okay. Nature of the image is virtual erect and size of the image is enlarged. Size of the image is enlarged. So check once all the image formations. Now we will discuss about concave lens image formations. Concave lens image formations. Concave lens image formation. Concave lens image formations. So we'll discuss now. So what we are going to do that, how the light rays will, how the light rays are moving, where image will fall. Okay, so where image will meet, everything will do, everything will discuss. So now you can see concave lens, concave lens, concave lens. This is a concave lens. Optic center F1, 2F1, F2, 2F2. So object is at infinity. Object is at infinity. How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object, right? So I'm taking 2 light rays. So here 1, 2. So we are extending these light rays. After extending, those are meeting at F1, 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 F1. So here this is F1, F1. So object is at infinity. Image will form at F1. Nature of the image is virtual erect and highly diminished. So object is at infinity. Light rays are meeting at F1. Image will form at F1 only. So nature of image is virtual erect and highly diminished. Virtual erect and highly diminished. Coming to the next one. Second one. Optic center F1, 2F1, F2, 2F2. Okay. Object is placed here. So we are extending these light rays. After extending, those light rays are passing through focus here. Okay, so the image will form. The image will form between F1 and O. Okay, virtual image. Virtual image. Object is placed between optic center and infinity. Between optic center and infinity, image will form between F1 and O. F1 and O. Nature of the image is virtual erect. Nature of the image is virtual erect and highly diminished, diminished, diminished. Okay. So coming to the lens. Coming to the lens formula, lens formula, lens formula. So lens formula will discuss. That is 1 by f equal to 1 by v minus 1 by u. M equal to height of the image by height of the object equal to v by u. V by u. So this is lens formula. Lens formula. Lens formula and magnification. Lens formula and magnification. Right. So that's enough. Next, we will discuss few problems. We'll discuss few problems. What are the daily life example of refraction? Daily life example of refraction. Refraction in daily life. Refraction daily life example. So anyone can say refraction daily life example. Refraction daily life example. Actually, glass slab is there. A glass slab concept is there. So we'll see glass slab, glass slab. Incident rays, I'm taking this a normal line. So refracted ray and emergent ray, this is, if you are extending this incident ray, if you are taking here this the extended incident ray, this is the emergent ray, incident ray, so refracted ray, emergent ray, angle between incident ray and normal line is called angle of incident, angle between refracted normal line is called angle of refraction, angle between emergent ray and normal line is called angle of emergence, angle of emergence. Okay, so the distance between emergent ray and extended incident ray is called lateral shift. So this is called lateral shift, lateral shift, lateral shift. Okay, lateral shift. The distance between emergent ray and extended incident ray, or initial direction of the incident ray. Normally, that is the initial direction of the incident ray. So that is called lateral shift. I'm taking the beaker. Okay, so I'm placing the coin at the bottom of the beaker. If you place the coin, so from one place you can't able to see. So here in this place you can see. From this place you can't able to see. Okay, you're standing over this place. So after pouring water, if you pour water, then we can able to see the coin position. After pouring water, you can able to see the coin position, right? So the position of the coin will rises up. The position of the coin will rises up. So until here it rises up. So this is the actual apparent position of the coin and actual position of the coin. Apparent position of the coin and actual position of the coin. Okay, so this distance is called vertical shift. Vertical shift. Vertical shift. Vertical shift. Okay, so the distance between emergent ray and initial direction of the incident ray is called lateral shift. The distance between this is the actual position of the coin, this actual position of the coin and apparent, the distance between actual position to apparent position of the coin is called vertical shift. Vertical shift. Okay, vertical shift. And also related to this one, two more examples we can take. If you are placing the lemon inside of the water tumbler, okay, it appears bigger due to refraction of light. Due to refraction of light, lemon appears bigger. Okay, the lemon appears bigger due to refraction of light. Due to refraction of light. And one more thing, if you are placing the pencil, if you are placing the pencil here, I'm placing the pencil over here, If you place pencil also, if you are placing the pencil also at the interference of the coin and wire, that interference of the water and air, so at here at this position, so it appears bent. Actually here only, the position is here only, but it appears to be bent. Okay, so this is about example for refraction. One is pencil placed, another one is lemon placed, another one is coin placed. And also, if you take the glass slab and place over a printed letters, okay, so it appears somewhat bulged out or raised up. Next one, pencil kept in water tumbler, twinkling of stars. These are the examples of refraction of light. And sun appears in the morning. So advanced sunrise and delayed sunset also due to atmospheric refraction. Actually, refraction takes place by the atmosphere. Okay, total internal reflection, daily life example, daily life total internal reflection example. So diamond shines due to refraction and total internal reflection. Okay, shining of lower surface of water when viewed through the down below. Okay, so air bubble also, air bubble, formation of mirages. Okay, lateral shift depends on, lateral shift depends on, example, on what factor lateral shift depends, on what factor, on what factor, on what factor lateral shift. Okay, so it depends on thickness of the glass slab, angle of incidence, and refract index of the glass and wavelength of the light. So few problems are there. We need to do problems. So thank you so much. We'll see in the next class. Okay, we'll see in the next class. Thank you so much for joining. At 6 o'clock again I'll start the class. Thank you so much for joining and attending the class. So this is Ever Shiva sir from Student the Brand. So if you like this video, do like, share and subscribe to Student the Brand. If you like the content, you can share to your friends, ask them to join to the class. So thank you so much for joining. This is Ever Shiva sir. And I pinned my Instagram page also, page link. So you can go and check. Thank you. Nice to see you. So we'll see in the 6 o'clock class today itself. Thank you all.